Okay, so I was cut off at number 19 in the last video. So what we started with was s equals 2a plus bh, and we're going to solve for h. So I highlighted the h. Before I could worry about this b, though, I have to move this 2a. It was positive 2a, so I subtracted 2a from both sides. That left me with s minus 2a is equal to bh. Now, I'm still trying to solve for this h term. So here's my h. The b is tied to that by multiplication, and the inverse to multiplication is division. So you can see that I already drew my division bars in here, and now I'm going to divide by b on both sides. Now I can't actually simplify this anymore because it's so many variables, there's nothing that can be combined. So all I'm going to do is rewrite it so that the h term is actually by itself. So s minus 2a, I'm going to draw my fraction bar, divided by, and then type my b, and all of that is going to be equal to h. I'll move that so it looks a little bit better. Boom, there's our answer. Okay, moving on to this next page. I think we're on to our next standard. 2.4, creating and solving inequalities. So we have an inequality here. So the difference is there's no equal sign. It's an inequality. This says greater than or equal to. But you're going to use the same inverse operations that you do with equations. So we first need to isolate the x, and then we're actually talking about graphing this figure over here. So solve and graph. 8x minus 12 is greater than or equal to 28. So I'm going to add 12 to each side first because I'm trying to get the x term by itself, and I need to add 12 to both sides before I can talk about doing anything else. So that leaves me with 8x is greater than or equal to, I'll have to put the equal to part out in a second, hold on, and that equals 40. I'm going to use my straight line tool. I can put in the equal to part right here. Very important that you keep your symbols correct. Okay, so 8x is greater than or equal to 40. My next step, I'm trying to isolate this x, so I'm going to divide by 8 because it was tied to it by multiplication, and the inverse operation is division. So then I get x is greater than or equal to 5. Let me put in my bar because it's important that I do this correctly. Ooh, undo that. Undo that. Greater than or equal to. Somehow it jumped there. I'm not really sure why. Okay, now let's graph it. So I have it's greater to or equal to. Greater than or equal to. So my dot is going to be filled in, and it's going to be on the 5. So I'm going to fill it in here on the 5. And then it's greater than or equal to. So my arrow is going to be going this direction. Please draw an arrow because that indicates that it's going on forever in that direction. There's my graph. Okay, number 21 is a little bit more involved. I have a variable over here, and then I have a variable over here, and I have the distributive property. So I'm going to pass this out to each of these terms with multiplication, and I'm going to write what I have. So I have 18 minus 3x. 3x is less than, and then so 3 times x is 3x. 3 times positive 2 is plus 6. Boom. Okay, now I need to get my x's onto the same side of the inequality. I look at the smaller one. So this one's negative 3x. The inverse operation to that negative or that subtraction is adding 3x. So I'm going to add 3x to both sides. That leaves me with 18 is less than 3x plus 3x is 6x plus 6. Good. So I'm one step closer. I need to continue. The inverse operation to this adding 6 is going to be subtracting 6. So I'm going to subtract 6 from both sides. That leaves me with 12 is less than 6x. My next step is the 6 is tied to that x by multiplication, so the inverse operation of multiplication is division. So I'm going to divide both sides by 6. When I do that, I'm going to get 2 is less than x. Now, I've talked about this in class. When it's written like this, I have a really hard time graphing it. So what I like to do is reverse the order of that so that the variable is first. So x, and sometimes it's hard to see which way the symbol is supposed to go when we're flipping it. Can you see though how the alligator is eating the x? So I need to make sure that the alligator is still eating the x here, so it looks like that, and then 2. So x is greater than 2. Because there's no equal sign under here, I know that my dot is going to be an open dot at 2. So I'm going to try my best ability to draw an open dot at 2. It's pretty good, not bad. And I'm saying x is greater than 2, so then it's going to be going this direction. Boom. Okay, next question. All right, so we have a situation here where we need to write the inequality and then to say what the solution is. So Gina is going to the grocery store to buy snacks for her friends. She has $31.50 to spend and wants to buy a bag of lollipops for $7 and bags of chips for $3.50 each. How many bags of chips can Gina buy for her friends? Okay, so think about this. When you guys go to the store, you can't spend more money than you have. So she can spend up to the $31.50, but she can't go over that. She doesn't have to spend it all. You never have to spend it all, but she could if she wanted to. So let's think about the situation. She has those bags of lollipops, and those are $7. Then she's trying to buy bags of chips, and they're each $3.50. So that each word indicates that there's going to be a variable there because we don't know how many bags of chips she's going to buy. So $3.50, let's say X for the bags of chips. Now she wants to spend less than or equal to that total amount that she has. So less than, and then I'm going to draw my symbol in here, less than or equal to, we'll go back up here, the $31.50. So here is my inequality. So you would get a point for setting this up correctly. Now we need to solve it. Looking at this, we're trying to isolate this x term, and what we need to do is move this 7 first. Since it's a positive 7, we're going to subtract 7 from both sides. Okay, that leaves me with 350x is less than or equal to, I'm going to put the equal to symbol in there in a second, 2450. Okay, let me put that bar in there because that's very, very, very important that we include that. Okay, next, it's 350 times x. The inverse operation to multiplication is division. So we're going to divide by 3.50. You don't have to have the 0, but you can. Divide by 3.50. That's going to leave me with x is less than or equal to, give me a moment to write that in there, 7. Now let me put my bar in there because this is important. Less than or equal to 7. So what that means, I'm interpreting this answer, that means she can buy 7 bags or less. And that's really important that we write that and analyze what this solution means. Okay. Moving on to the next standard. So this is compound inequalities. Compound inequalities is when we have two inequalities together, and they can be combined with this or they can be written together in an and situation. So let's look at this. We have negative 7x is greater than or equal to 49, or x plus 6 is greater than 4. So we're going to solve each of these individually. I can interpret right here that this negative 7 is tied to the x by multiplication. So what we're going to do is divide by negative 7, because the inverse operation to multiplication is division. Now we're dividing by a negative 7, and when we do that with inequalities, our internal alarm, the woo 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 that we talked about in class, that means that we need to flip this symbol. So I'm going to be left with x is less than or equal to, and let's divide this out. 49 divided by negative 7 is going to give me negative 7. Now let me put my bar in here because the symbol is now a less than or equal to symbol. Okay, so here's one part of the solution. Now I'm going to go over here and I'm going to simplify for this x. It's saying x plus 6 is greater than 4. The inverse operation to addition is subtraction, so I'm going to subtract 6 from both sides. That leaves me with x is greater than negative 2. I'm going to put a word in here that's very important, or. So my solution now is x is less than or equal to negative 7, or x is greater than negative 2. So let's actually graph these. Because it has this equal to symbol underneath here, I'm going to put a filled in dot at negative 7. So negative 7 has a filled in dot, and it's saying x is less than or equal to that. So my arrow is going to be going towards numbers that are less than negative 7. Okay, then we say, or x is greater than negative 2. Since it's just greater than, the negative 2 is not included, so I'm going to have an open dot at negative 2, and then it's pointing to things that are greater than that term. Okay. Whew. We have another one here. Now this one is an and situation. We're trying to solve for the x to get the x by itself. So we need to remove this minus 9. So doing the inverse operation again, we need to add 9 to all sides of these inequalities. So I'm going to add 9 there, add 9 over here, and also add 9 to the other side of this inequality. So there's 3 locations where we're adding the 9. Okay, negative 10 plus 9 is negative 1. In the middle, I am left with just x. And then less than or equal to, I'll put the equal to symbol in there in a second. And then let's add negative 3 plus 9 is 6. We've simplified this now to have x alone in the middle. And we have negative 1 is less than x, which is less than or equal to 6. Now let's graph it. Because of this symbol right here, I know that it's going to be an open dot at negative 1 because it doesn't have that equal to underneath. So negative 1, it's going to be open. And then it's going to go all the way to positive 6. And 6 is going to be filled in because it does have that bar underneath it there. So I'm going to have a filled in dot here. And then I would connect these two because x is physically between negative 1 and 6. And that's it for this question. Okay, 2 more problems, and then we'll be done. So this one has 2 steps. We have to isolate the x in the middle here. I'm going to pause this actually, and we'll start another video.